One of the things we spent time on in our first chapter on regular waves was what happens when you have standing waves. The same thing happens with sound. We have standing waves that's going to look a little bit different because you're not just talking about a string, which is really all we addressed last chapter. So here we're going to review what it looks like with those standing waves with strings, and then we're going to add a couple different formations of sound waves. So to begin with, standing wave is what happens when we said if you have a pulse, the pulse will go down a string, reflect, and come back. But if you continually make pulses at the right frequency, you get an interference pattern that is a standing wave. So that's what a standing wave is when incoming and exiting pulses overlap and give you that pretty football pattern that we looked at last chapter. So things that are going to change what these standing waves look like as we relate them to sound. The speed of the wave is going to change that frequency, so that depends on the medium that's used. The actual size of the object, so think about like a piccolo is like a tiny little flute if you've ever seen a piccolo, and it's a very high-pitched instrument compared to like larger flutes. The same thing happens in other instruments. There's alto saxophones and bass saxophones, and they're basically the same instrument, but the larger the object, think about like the deeper the pitch it's able to have because the size of the object dictates its wavelength. And then the third is the type of boundary that exists at the end. So if you remember from last chapter, the types of boundary that we talked about was a free end or a free boundary. And if you have a free end, you end up with an antinode, and I'll show you this in a demo in a bit. And then a fixed boundary is where you'll have a node set up. So the fixed boundary would be like we talked about with the strings, where the strings had the football and each end was a node. And then the free boundary we didn't see before because we only talked about strings. So we're going to see how sound can set up a free boundary. As we look at this, there's a whole new set of terms that appear when you start studying sound. And they can be a little bit kind of frustrating, but you've got to take a little bit of time and figure them out. And once you have them figured out, it's going to be okay. But you've got to kind of make sure you understand them really well the first time. And that is telling you how many waves you have. Just how we had last chapter, how we had the first mode and the second mode and so on and so forth. We're going to do that same thing here by adding waves as we increase modes, adding number of waves. So the terms that we used last chapter was this idea of modes. So the mode is each successive vibration that can create a standing wave. So we know we can't have like 1 1/3 of a string wave. It just doesn't work that way. So between first and second mode, you add half a wave, and then you'd add another half a wave as you go to third mode, and another half a wave as you go to fourth mode. So another set of terms that goes with this, we already said that the first mode was the fundamental. That should be something that you're comfortable with. What we add in this chapter, first of all, is the idea of overtones. So in with fundamental, there's a set of terms that goes with it. So the fundamental is, think about that as the lowest note in a chord, if you know anything about music. The first overtone is going to be the next mode up. But because it's 1 over the fundamental, it's the first overtone, but it's the second mode. So that's the thing that's a little bit confusing. So overtones just mean 1 off of the mode of vibration, but it's a sound term that gets used in mostly talking about music, but in with the sound section, you'll hear that terminology used. So then one other idea that goes with terms is the idea of harmonics. So the way harmonics work is a harmonic is what multiple of the fundamental is the frequency that you're looking at. So we talked about in the last chapter how if a string had a fundamental frequency of 100 hertz, the next mode up was going to have 200 hertz, and the next mode up would be 300 hertz, etc. And so we said that was the first, second, and third mode, which is true. That is also the first, second, and third harmonic because the third harmonic is 3 times the fundamental frequency. Okay, so I think that should make sense based on what we've talked about already. What we're going to do is differentiate those into strings that we've already talked about, open tubes, which we're going to add. Open tubes has the same wave numbers as strings do, so when we talk about that, that should be pretty okay. And then the last one we'll talk about, and I'm going to include this a little later, not yet, so hang on for this one, but it makes sense to put this in with harmonics, is the idea of closed tubes. When we do some of the homework, you're going to see that if you have a closed tube, if the fundamental is 100 hertz, the next mode up is actually going to be 300 hertz and then 500 hertz. So there are no even numbered harmonics. There is no 200 hertz. And you won't really understand that, I think, until you get to the homework. But you're going to see that pattern emerge. And when you come back and look at this, hopefully that'll make a little bit of sense. So we've already talked about strings. So this part is kind of review. But for a string then, we have I put the first 3 modes on here, but you could keep going. And we've talked about how each football is half a wave. So the first mode here is half a wave, and I have the half a wave up here. There is a lambda here, but for some reason it isn't displaying on this version of the PowerPoint. So I have first mode, second mode, and third mode. Okay, now how does that work with the overtone terms we just talked about? We said the first mode is the fundamental frequency, so the second is the first overtone, and the third mode is the second overtone. That's always going to be true for these overtones. They work just like that. What harmonic is it? Then this is going to be the first harmonic. It's going to be the same as the mode number for strings. Second harmonic, and third harmonic. So that's how those work. The number of waves is above, so this is 1/2, 1, and 1 1/2, or 3/2. So that should be somewhat familiar in that we've already talked a little bit about these. To understand the solid objects in open tubes, you're going to have to, I'm going to make a video of what it looks like to make a standing wave in a bar, and until you see that, it might not make a lot of sense. But I'm going to go through it here, and then you need to watch the video where I show you that. So I'll hit some demos in this chapter, but I'm not going to do that here. So if I'm going to do a solid object which has exactly the same, form as an open tube. So these are two things that have the same form. So my very first mode on this, what I'm going to find is I'm going to set up an antinode at the end instead of a mode, or a node. So this is my first wave, and then my other one, this is it flipping up and down just like the string does. So if I took a photograph of it at any given time, I would only see one line or the other. So what you're going to find is that here, if the air is going from the solid bar into air, think about that change in linear density that we talked about last chapter, where we said if you went from heavy to light, that the reflection would not invert, and you'd have what is called a free end reflection. So this would be a standing wave that forms when you have a free end reflection. So when I do this, this is always the same waveform for a bar or an open tube. Okay, same idea each time. Now when you see an open tube drawn, while I have this up here, an open tube, like if that would be my tube, and they ask you to draw the wave, you just draw the wave inside the tube like this. So it's exactly the same waveform. On the bar, you kind of draw it on top of the bar. On the tube, you can draw it inside the tube. So let me add then my next forms up for here. So this is my fundamental. Every time I add a new mode, as I increase modes with a bar or an open tube, you're still adding half a wave. So this guy, this whole side is 1/4 of a wave and 1/4 of a wave. You can see if I put those together, it would actually just be a football. So that's still half a wave, which is right here. So if I increase to the next mode, I'm going to add half a wave each time. So plus 1/2 wave gives me the next one. When I go to the next one, it's going to look like this then. So I've added, here's a football that's 1/2 a wave, here's a quarter wave, and here's a quarter wave. And those add up to 1 full wave. So that is my first overtone. And then I'll go back and hit those other terms at the end here. So that's my next one. And then when I add another one, another easy way to think about this with open tubes and bars is adding an X. So I add an X here, and now I'm at 1.5 waves. So I've got 1/2, 1/2, 1/4, 1/4, so I have 1.5 waves. But notice each time I'm adding 1/2 a wave, which think about as adding an X to get to the next one. If you add an X each one, you're increasing modes. So let me hit the terms that go with this then. So I'm going to clear the markings I have here to give myself some more room to write. So my fundamental frequency, so this is my mode 1, mode 2, mode 3. So there's my modes. Using the overtones, this one overtone is your fundamental, overtone is your first overtone is second overtone. So it's one off of the modes. And now my harmonics would be the same as the modes for this one as well. It's only different on the closed tubes. And I'm not going to do closed tubes in this video, I'll do it separately. So this is harmonic 2, harmonic 3, okay, and then the number of waves we've already talked about is 1/2, 1, and 1.5. And I know this is new and a little bit different, but it's always going to be the same is the good news. So once you see those, they're always the same. And I think that is the last one that I'm going to do on this video.